Hi everyone, welcome to COP 3502 Programming Fundamentals 1. This is module 0 of the course, which is Introduction to Computer Science or Computing Fundamentals, and in this module we learn a little bit about what computers are, what are the different areas in computer science, what kind of career options are available in computer science, and a little bit about the Python programming language. So with that, let's get started. What is computer science or computer engineering? The formal definition of computer science goes like this, which is it is the study of computers and computational systems, including the design, theory, development, and testing of such systems. Computers hold great potential and they are very complex. We are surrounded by computers almost everywhere, and they can be used to solve a variety of different problems, such as some of the goals that are stated by the United Nations Sustainable Development Group, which are pretty large problems which impact society. For example, like let's say if we talk about one of these goals, which is reducing poverty, which is like no poverty. Some of you might know that in Gainesville, about 30% of the citizens are below the poverty line, which is they make less than $25,000 a year for a family of 4. So CS can be used to solve a variety of problems, such as reducing poverty by providing maybe people who earn less money more education related programs by harnessing computer science, or by providing them transportation tools so that they can reach to inaccessible areas to get more jobs, or to prepare them for computing jobs itself so that they can earn more than what they are making right now. So whenever we have computer science that is trying to solve societal problems, sometimes it's very hard, like these problems are hard and we should know the limits of computing. And once you take more advanced courses, like let's say human computer interaction or artificial intelligence and machine learning, you will realize that there are some sort of biases that are associated with computers, and you need to make sure you know about those biases. Otherwise it could have an adverse impact on the society rather than a positive influence. But in general, I think like nobody is going to disagree to this, which is computers have had a net positive impact on society if you look at the last few decades. There are many sub-disciplines or sub-areas within computer science because it has grown so big, which include some of these areas might include like software development, which is more related to programming, or software engineering, which is more related to programming plus the processes that are associated with programming, or computational theory, which is studying the formal aspects or mathematics as well as proving whether a program is going to work or not and stuff like that. But in general, all of these different sub areas kind of are geared towards solving a particular problem. Okay. One question a lot of folks might ask is, what is the difference between computer science and computer engineering? Which is, they are essentially two sides of the same coin, but I would say that computer science is more geared towards building systems or software systems, while computer engineering is also geared a little bit more towards hardware and combining both software with hardware. There are lots of different areas in computer science. Some of them are listed here, which is artificial intelligence, cloud computing, data science. And nowadays, a lot of these jobs might be specialized in some of these areas. So what you can do is, like I would highly encourage is, once you're starting the degree program, maybe till you are a sophomore, explore the courses that are required. And maybe once you are a junior or senior, take some specialized courses in some of these areas which might be of interest to you. If you do not know about any of these areas, the best way to look about what these areas entail is to go through, there are a lot of resources on the web that kind of expose you. One resource I can mention is, like, if you just Google or go to YouTube and search what does a career in AI look like, or what does a career in cloud computing look like, A lot of these big tech companies have created short videos explaining what some of these areas entail, and I can provide you links if you can't search these. But just to give you a sense on what these areas entail, which is artificial intelligence is pretty popular right now. It covers how can we make computers that can learn independently on their own on solving a particular problem. Cloud computing is the study of systems as well as how to scale. Let's say if you have developed some infrastructure and you want to scale a website or a application or software application to billions of users, how can we use infrastructure to host that, to deploy it, and to maintain it without like using our own servers, but instead using something called the cloud. And nowadays there are a lot of cloud providers such as Amazon Web Services, Microsoft Azure, there's Salesforce, Oracle, there's Google Cloud Platform. How can we use these resources which are provided by other companies so that we can host our own web application or software? Data science entails dealing with data and solving problems by observing patterns in that data. Python, which is the language we are going to use, is the most popular language out there to do data science work, and data scientists often use to make business decisions observing patterns in the data. Another area is Internet of Things, which is like, let's say if you have a lot of sensor data, you might have Amazon Dash buttons, or you might have different devices like Apple Watch or whatever. They might be connected to an ecosystem of different computers, and they might be sharing data across each other. Or these smart devices like Amazon Echo or Google Home. How do we how do we make sure we can communicate with each of those devices and build software focused on that? So that is what Internet of Things is. UX, user experience, is essentially a field that encompasses a lot of other fields as well, such as psychology, sociology, anthropology, along with computer science, and it focuses more on providing the best experience out there for a user, which is how do we run studies once we have developed computing systems to make sure we are making good products for the end user or a customer, rather than for somebody who might not be using that product. HCI is again related to human factors, which is the study of how human beings think or interact with systems, along with how do we design those systems more geared towards actual users rather than just making them for the designers or software engineers who might not be the end users of the system. Robotics encompasses a lot of hardware. How do we build robots to do a variety of stuff? There are a lot of cool videos out there on YouTube. You can search like Boston Dynamics. That's a great company that does robotic stuff, but there are a lot of other companies too. Graphics deals with computer graphics. Like, this is computer graphics, which is not graphic design, but technically how do we write software code or represent computer graphical software in computer science, along with the formal theory of graphics as well. Databases would entail how do we store that data into different types of databases, which is structured databases or NoSQL databases and so on. But all of these areas, like throughout the computing program here at UF, you'll be exposed to these areas through different courses that you can take either as a required part of the curriculum, or you can take like optional electives. Computer architecture would deal with how do we create like compilers, or how do we create like computing systems from scratch, including how do we build their instruction set and so on. The most popular out of all of these areas is software engineering, where most students would land jobs into, because that's where most jobs are, which is either software engineering or web development. which includes building systems which are used by like billions of users, because at the end of the day a lot of users would interact with software, which is like, let's say if you interact with Google, Microsoft, or I'm right now recording this video on a piece of software. So those are some examples. Computer security is also pretty popular and it's grown pretty big. I think it's projected to grow at almost like 15 to 20% a year, and there'll be millions of jobs in computer security. Also, UF has a excellent program in computer security with a lot of courses and world-renowned faculty. So if you want, you can take like courses in computer security, including stuff like blockchain and other different concepts. Networks is the area that deals with computer networks. How do you pass data over the internet through different protocols and stuff like that. VR is also getting pretty big, which is like a field that is associated with virtual reality. Some of you might be familiar with Oculus and other VR tools that are out there, Google Cardboard and stuff like that. And then you have web development, which again can be distributed into several sub areas like front end, back end, and full stack development, and so on. And then there's game development and testing, which are also pretty popular. So what will you learn throughout the course? You will technically be learning problem solving, not only in this course, but the entire degree program. You will learn to solve different problems. Get ready to fail a lot. Like, even though you might be a superstar in your high school, you might be getting like a full GPA in every course. Once you take more college courses, expect that you're going to fail a lot, especially there'll be some assessments which will be very hard. But the good part is, like, as you are failing, you will learn a lot, and through these errors that you'll make sure that subsequently when you encounter the same error, you have the capacity to deal with it, which is you have access to resources, which is peer mentors, instructors, your colleagues, your peers. Feel free to talk to them whenever you are stuck. But again, you'll be learning a lot. But one of the things that you need to ensure is you do not give up, which is a computing professional or a software engineer or a computer scientist has these qualities for sure, which is grit, resilience, and determination, which is basically an attitude that no matter if you're failing, you still have to keep going and spend considerable time to understand whether you like the field or not. That's what I would recommend. The only thing that is required from you all is to put in the effort, which is you need to put in time. And I know several students who might be struggling in the first course of computer science, getting a good grade, but after the second or third course, they feel very comfortable and they have excelled in the program, gotten jobs worth more than 100K or something. That's like the average computer science degree programs, like graduate salary from UF, which is great. So what you need is to make sure you have the determination and you put in the time, and the rest of the things will follow. Another resource I would like to suggest before I end this video is, if you go to the UF Computer Science website, if you go under academics or under research, if you go under research areas, there are a lot of areas at UF like AI, ML, algorithms, bioinformatics, and stuff like that. You can read about these areas by looking at any of the, like, either Googling the name of this area, or if you're interested in working on research or maybe exploring what is going on currently in the field, you can look at the faculty who is working on these areas. Like, for example, one person is Bonnie Dorr. She's a very well-known professor in the field of natural language processing. So maybe you can look at her recent work and understand, what is going on in these areas and so on. Like, I'm just giving you a sense. Another resource I would highly recommend is the UF ACM website. Like, this is another way you can get exposure to different subdisciplines, which is ACM has different special interest group like programming team. InfoSec is related to computer security. or Gator VR, an open source club. Like, there are a lot of student organizations on campus, so if you can get involved in these, you can learn about these sub areas before you take like formal courses in this area and devote time to these areas. The last thing before I end the lecture is we are going to talk a little bit about what is a computer, which is, at its core, a computer is nothing but a machine that executes instructions. It's just like a calculator. There are four big parts of every computer, which is, the number one is called the input. The second one is called the CPU, which is kind of the brain of a computer. Memory is also called like storage, which stores the data in a computer. And the last one is output, where you receive the result of some input which has been processed or stored in memory, and then it is received to us through output means, which is, just to give you an example, like let's say if it is input, you can get the input from the mouse or the keyboard. Other forms of input might be, like let's say if you're using an Apple Watch, it might have sensors. Your cell phone has sensors, so those are means to get the inputs from a user. CPU is the central processing unit where all instructions execute, which is, you might be writing some algorithms or you might be writing programs throughout the curriculum, so those get executed on the CPU. And CPU has access to memory, where you might be storing this input, or you might be storing processed input, and then the processed input might go from the memory to output in the form of visual output, such as watching it on a monitor or your laptop screen, or it could be auditory output, such as getting it through the speaker. It could also be sensory output, which is like, let's say if you have a cell phone, your cell phone might vibrate or something, or it could be other forms of outputs as well. But in general, computer is nothing but, it's fundamentally a calculator, and all the data that is stored in a computer is in binary format, which is the format of ones and zeros, because it's made out of very, very small units, which is called transistors. And a computer might have billions or even trillions of transistors, and these transistors would represent states, which is like 0 or 1s, which is, you can think of it as a light bulb. So a computer might store is formed out of all of these transistors, which might represent on or off states. And there's this concept of abstraction, which is, you can represent data through these transistors, which is, if they are on, that means like you have 1, and if they are off, that means it's like 0, which is like, you can think of it again as a light bulb. And you can represent these light bulbs, you can represent information through these light bulbs, which is, this light bulb, which is 0 and 1, represents something called a bit, which is, a bit is one unit of information that can store two states, which is 0 or 1, and this is just one bit. So one bit can code two types of information, which is, in this case, like let's say if I have a system where I want to represent A and B, I can represent it by one bit, which is, I can have a bit where I can code that A is 0 while B is 1. I'm just making this up, but this is how it is. While if I have another character like C, I might need an additional bit to store C, which is, what I can do is I can have 2 bits, which is, if I have 2 zeros, then it will be maybe A. If I have 0, 1, then it's B. Then if I need to represent C, that will be like 1, 0, and so on. So you can represent the entire character set, which is like, let's say if you have Unicode, which is comprising of Chinese letters, Japanese letters, English alphabet, 0 to 1, 0 to 9, all the numbers, all the characters like star, ASCII, star, divide, plus, all these symbols, they can be represented in the forms of zeros and ones by coding them into some number. And we are going to learn a little bit more about all of these principles. But in the next video, what I would want you to focus on is to learn a little bit more about what a computer is. It's an excellent video from code.org. And then we'll come back and we'll start looking into what are compilers and interpreters, as well as how Python works in our next video after that. Have a wonderful day, everybody. Take care.